So for our first homework assignment, we were supposed to make a program that used recursion to find the greatest common denominator of two integers. So I started my int main by allowing the user to enter in two integers and store them in m and n, and then I passed them into the GCD method. So this method stores the modulus of m and n and stores that into r, which is the remainder. And if this remainder is 0, then we know the greatest common denominator is the second number. If it isn't, we just use recursion and we pass in n, which is the second number, and the remainder. And this will pretty much keep calling or keep recurring until it finds um, the correct greatest common denominator. So I'll just use an example: 32 and 12. So it'll be GCD of 4, and this is because the remainder will not be 0, so it'll call it again. It'll put in 12 and 6, or no, 12 and 8, which would be the remainder of 32 modulus 12. But when it does this, it still won't be able to get a remainder. So it'll pass in 8 and 4 after that. And then since 8 modulus 4 will give you a remainder of 0, then we know that 4 is the greatest common denominator. So for our second assignment, we were supposed to make a program that reverses an integer that the user enters. So in my main, I allow the user to enter in an integer, and I pass it into the reverse display method. So what this method does is pretty much set digit equal to value modulus 10. And what this does is pretty much remove the last digit of this number. I then take this value and divide it by 10 and set that equal to value to pretty much remove the last number. So if the initial value is like 123, modulus 10 will store 3 into the digit, and then we divide 123 divided by 10, and it'll give you 12. And then we see out a digit here, which would be the last number of value, but it'll be the first number when we reverse it. And if this value is equal to 0, we know that we're done and we just return. But if the value is not 0, then we use recursion to call reverse display again. So it'll pretty much do this until there is a value to print out. So I'll just test my program. I'll enter in 4, 5, 8, 7. You can see it reverse properly by giving 7, 8, 5, 4. So for our third assignment, we were supposed to make a program that converts a decimal number into hexadecimal number. So I started by allowing the user to enter in any number they wanted to and storing that into V. And then I passed that into the 2-hexa method. So up here, our base case is V equals to 0. And in this case, it just returns nothing. It doesn't use any recursion because we want the recursion to end once the last digit is 0. So in the case that it's not 0, it just uses recursion. We take V modulus 16 and throw that into R, and this is the number that ends up being outputted to the user to convert into hexadecimal. We then take the value and then divide that by 16, and then this is the number that ends up being passed into the recursive call of the 2-hexa method. So after this, we have a switch statement, which takes care of every single number. The first cases are in the event that the number is greater than 10, because in hexadecimal number, numbers that are greater than 10 are represented as letters. So this is take care of that. And the default case simply converts the number into a string and stores that into hex. And we return a string, and then this hex is just concatenated onto whatever 2-hexa is. So this recursive call pretty much just concatenates a bunch of different conversions. So I'll just test my program real quick. So I'll just convert 465, and it gives me 0x1d1. And when I look up a actual conversion online, it gives me the same number. So for our final assignment, we were supposed to make a program that solves the 8 queens problem using recursion. So I started by making a 2D array of strings called board, which is meant to simulate a chessboard. I then used 2 for loops in order to make every single individual element in the board array just be empty. I then passed both these variables into the EQ method, and this is where the recursion happens. So in this method, we pass in the 2D array and also a number, which stands for the row that we start on. Because this method uses recursion in order to find the first empty element in an array and sets that equal to a queen. So our base case is if row is equal to 8, because if the row is equal to 8, then that means we have successfully placed 8 queens on the board. So we just print out the board and we return true. So moving on to the for loop, this for loop iterates through every single column in a row, and this if statement pretty much evaluates to see if that row and column of the board is empty. And if it is empty, then we know that it's not covered by any queen. So we put in Q, and also we convert the row into a number to signify which queen number we put into this row. So after this, we call the add conflicts method, and this method pretty much adds in any. It pretty much fills the array with numbers signifying which squares a queen guards over. So if a queen was placed on the top left, which is row 0, column 0, we would place ones, or we would place zeros for the entire row, and then zeros for the entire column, and also zeros for any diagonal it controls. After this, this is when we use recursion in order to, recursively call, and also to solve this problem. So we call EQ with board and row plus 1. So what this does is we will pretty much do this all over again except for row 2. So we will do this all over again, add conflicts for that, and so on and so forth until we successfully solve the program or the problem. But in the case that we do not find any suitable location, so in the event that we do not find any empty squares that we can put a queen in, we have to backtrack. So this occurs here. We call the remove conflicts method, and what this does is pretty much removes all numbers in the array, which is equal to the row. Since we use this to signify the queen, we use the row number to place numbers on the location where that queen guards. So we know which queen is responsible for what, for control of a certain square on the board. And we also set that board and that row. We set the board, row, and column equal to empty, and this is to pretty much remove that queen from the board. So now I'm going to move on to explain the methods that I made. So for my add conflicts method, we pass in the 2D array board, we pass in the row and column, and also qnum. And qnum is pretty much just row again, but since we use this R in the for loop and it ends up getting adjusted, we want qnums to stay static so we can input the correct number into the array. So our first for loop here is meant to add vertical conflicts, so it pretty much adds every single row underneath a queen so we can know that it controls those certain squares. So here in this for loop, it pretty much just adds R plus 1, so it goes over every single row from where the queen is to less than 8. So first in the for loop, we check to make sure that the board row and column, first we make sure to check that it's empty, because if it's not empty, we want to keep the precedence of control. So if a earlier queen controls a square, we don't want a future queen to just have precedence over that square. So here we take board IC and make it equal to qnum to string. So it'll just set every single row equal to the queen number. So the next for loop is meant to take care of downward left diagonal conflicts. So we start by setting steps left equal to C. And this is because we are looking for left diagonals. So if we start on column, this would be column 2. We know that we have 1, 2 to the left. So the most I can control to the left is 2. So we start at here, which is 4. It could be 1, 2, 3. So that'll pretty much take care of every single diagonal to the left. So to do the diagonals to the left, we add 1 to the row, and we subtract 1 to the column, because our rows are going to the left and then it's going down. So that'd be plus to the row and minus to the column. We also check to make sure in this system here, we check to make sure that our rows and columns aren't going out of bounds. And we're also checking to make sure that the inside of whatever element is in that row or column is empty. So we don't override any other queen taking control of that given square. So once all these are satisfied, we set that given index in the array equal to the queen number. So that'll take care of any left diagonals. And the final for loop is meant to take care of downwards right diagonal conflicts. So it's pretty much the opposite of downwards left diagonal conflicts you see here on row 2. We have 1, 2 to the left. So if it's 1 to the left, then we have 1, 2, 3, 4, 5. So that'd be 7 minus C. So that would always give you the correct thing. You can also see this. This is 0, 1, 2, 3, 4, 5, 6. We have 7 minus 6, so to give you 1 to the right. So this steps right would be 7 minus C, so we can always have the correct number of steps. We start the for loop the same way we started the one up here. And then here, for the row and the columns, we add the row because we're always going down. But since we're going to the right this time, we add to the columns instead of subtracting. And now this does the same thing it did up here. This if statement is trying to make sure that we stay within bounds. And since the to the right column would be 8, then we change this from 0 to 8 here. And then we also make sure that the inside of this element is empty because we don't want to override any other queen. So if all these conditions are satisfied, then we are ready to make this index in the array equal to the number of the queen that it controls. So for the remove conflicts method, this method is used in backtracking to remove any conflict of a queen that's about to be removed. And the reason why a queen would be removed is because there are no valid solutions for this queen. So first we have to convert the number of the queen to a string so we can compare the inside of the array, since the array is a string. So we use a nested for loop to iterate through every single row and column of the array. And if the inside of that array is equal to the string C, then we just set that element to be empty. And we do that for the entirety of the array. So that'll get rid of any single number that used to stand for a queen controlling that square. So for the final method is the print board method, and this method is used whenever we successfully find a solution and just used to print out the board. So we have a nested for loop that iterates through every single row and column of the array, and it finds that if the board element is equal to Q, if the first element is equal to Q, then we just use a substring because we only want to print out the number just to make it have like better spacing. And in any other case, whether it has a number or it's just empty, we just print out dots because we don't want to have the numbers to print out to the user, since those are only used to determine just to help out to figure out whether a queen guarded a certain square or not. So now I'm ready to run my program. Here you can see it just prints out a simple number for every single queen, and we can see that every single queen is in an individual row and column, and they share no diagonals. So you know that my program solves the 8 queens problem correctly.